I had a great weekend. It's as always.
Always.
It's actually very I think refreshing to
Yeah.
to know the I guess the to be going to be at a different place at the weekend. We have a sort of a family retreat at another part of
Oh,
Thailand.
nice.
Yeah. So that's kind of been regular for me on weekends.
Okay.
And how about you?
It was all right. It was nice to take a break, even though it was short, but
Okay, okay, all right.
a break is better than nothing.
Okay, good. All right. So yeah, I think it's something I learned is you have to take time to recover, to rest and
Yeah.
recover, which is always kind of important, right?
Yeah.
Because that
I
will supplement your energy.
yeah. I'm learning that the hard way. Um,
Oh,
when I was younger, I could go 3 days straight without
oh,
sleeping or eating.
right. Okay, yeah,
But
but
nah,
probably you should take something.
yeah.
All right. So yeah. So I think let's get to the sync. All right. So yeah,
Okay.
please do
Uh,
update. Okay, on your
uh,
progress.
so you said Herman is not joining? Um,
I'm not sure. That's. I mean, can you right? But I mean, we can. I think we can start. Right.
all
Yeah,
right.
we can just start.
All right.
So
No
go ahead.
problem.
Go ahead. Yeah.
So can you see my screen?
Yes.
Let me
Yes.
zoom
Yep.
in.
Yep. That's good.
Okay. So I think this was the major change I made with the graphs, basically to add like an uptime kind of data analysis. I'm basically speculating that we're gonna have a 99% uptime, rate where we are uptime 99% of the time. All right. But majorly though, I focused mainly on consistency, and it actually took me down a very deep rabbit hole. But I'll try my best to sort of summarize it. Oh, sorry. Um, so basically, the consistency when I did the research, a lot of it was using games as like a reference point. There's basically consistency in servers and consistency in P2P systems or P2P
Hello.
architectures.
Sorry, I didn't get the last part.
Uh, can you hear me now?
Yes. Yes. All right. Okay. Is my voice clear?
Yes, it is clear.
Okay. All right. Go ahead. Go ahead. Yeah. Go
Okay.
ahead.
So basically, I was saying I did research into consistency. Basically, it took me down a very dark, like a very long path. But the most of the research papers focused on gaming, consistency in gaming. I think it was like the best way to explain consistency. And basically, I noticed that for normal server client type architectures, there's a way they define consistency, and also there was a way they define consistency um, in P2P systems, in torrent-based, architectures. So in this, I sort of put everything together in one because a lot of them were similar at the end of the day. But so with consistency in games, right? Sorry, consistency in games. One of the first questions to ask was, where do I see the object? So, from a gaming perspective, now they defined it as two people. There's you, and then there's the guy on the other side of the
Right.
computer,
Right.
right? And where's the object you see? And then where's the client? Do you see? Where does the client see the object, right? And who is in charge? Apparently, that's a big part of consistency. Which part of the two, is authoritative? Now, if one is authoritative, how do you enforce agreement, or how do you force agreement between both? The both users. So
Right.
in a generic case now, we have a server and maybe two gamers, right? So
Right. Right.
the idea is who is in charge, right? Is it the gamers in this case who decides the the state of the game? Is it the first gamer or the second gamer, or should I say, is it the first person that made a move or the second person that made a move, right? So that's in a normal. Now in a P2P architecture, it's basically which pair makes which pair is in charge. Who is the super pair? I think that's in our case now.
Right.
Who is the super pair? So how do you enforce the agreement once you have the authority figure now? Like when do you render a move? Do you wait for everyone? Do you wait for all the packets to be delivered? Or do you just guess and try to fix the errors? So there I noticed that there were different types of consistency, and I'll get to them, later down. But basically, like if there are errors, um, how do you, I mean, if all the packets were not delivered, what do you do as the authoritative figure? Do you fix it? Do you just continue and pretend like no big deal?
I see. Okay.
Yeah. So there are ways that they counteracted that, and then I go down. I'll talk about that a little bit later. Also, the latency basically is what sort of determines all of these things. The reason why there are errors in the first place is most times because of latency. There's like a drop in packets or something like that. So
Okay. Right.
I sort of defined it. This is like a generic definition where you're talking about the local state, so that's the state on the device, and then the universal state, that's the state across all the across on the server, right? That's the
Right.
world state. I think some papers called it world state. Anyways, so once that was defined, it was sort of clear as to, okay, this is what happens here, this is what happens there, and then we can define what each pair uses, right? So now this is where the research sort of goes quite deep. There are different types of consistency, right?
Right. Yeah.
There's the pessimistic consistency. I think there's the optimistic as well. I feel like I wrote that down somewhere. Yeah,
Right.
optimistic.
Yes.
Yeah. There was this game I noticed, Age of Empires. They used, in this case, I think they used
Right.
something called bucket synchronization,
Right.
where the
Okay.
idea was each player, creates their own world. So the only information that is sent is the moves in that world. So it
Right.
reduces the sort of amount of data that is sent across the network, and it's just
Mhm.
sort of positional data, if that makes sense. Right. Now they send
Yes.
moves only, yeah.
Mhm.
Also, bucket synchronization, it resends drop packets. If anything was stopped, it resends it. It adjusts the sizes, it monitors the round trip time.
Oh yeah.
I noticed that was it.
Just to quickly make sure you understand. When you mean send moves, does that mean commands or positions?
So I think it's positions.
Okay.
The
All
idea
right.
is, if you're in the world, you don't need to send the world data, the entire world data. If you have created, so if you have created the world and they have created the same
All
world,
right.
you
Okay.
are
That
just sending positive. Yeah.
I see.
It's
Let me
mainly
just sort of clarify a bit on this. All right.
okay.
Because
Okay.
this is important for you to understand. I think sort of as a background knowledge. Okay.
All right.
Which is there are main types of consistency approach in games.
Okay.
Okay. One may be called update base. Okay, update base. The other may be called state base. Okay. What
Okay.
this means is that sorry. That let me sort of backtrack a bit. Um, one of the ways is for you to for all the nodes, all the players to continuously send out their positions. You
Okay.
see, okay, like their current positions, okay, their latest positions. This is what games like first person shooter (FPS) does.
Okay.
Okay, so you are basically sending, or rather flooding, everyone with position updates. Okay, like all the time. And the idea is that I the reason why they do this, and it's being sent out with UDP usually. Okay, so that means
Okay.
it's quickly delivered, but may not be sent reliably, or maybe out of order. Okay, you
Okay.
see, but that is fine. Okay, the reason is that these positions are usually time stacked. Okay,
Okay.
so the receiving end can basically try to sort of order them, and then try to present a view as accurately as possible at the receiver's end. Okay, that
Okay.
makes sense.
It makes sense.
Okay.
Yeah.
And even if you drop a packet or two, it doesn't matter. Okay, because you will always try to use the latest position updates.
Mm.
Okay. All right.
Yeah. Yeah.
So this is one approach. Okay. Now there's another approach, which is when you talk about the Age of Empires. They cannot use this. The reason is that these the one I just mentioned may be called state-based consistency models. This is
Yeah.
how I describe in my in my previous paper. The reason is that you're sending game states to update other machines to keep the
Yeah.
consistency going. Okay.
Mm.
However, it doesn't work. It works for something like first-person shooter, where maybe it's just like up to like 16, 32 players at most, like communicating with each other. However, in Age of Empires, there's like hundreds, if not thousands, of entities are moving all at the same time. You see,
Okay.
if you have played
Yeah.
these real-time simulations, right? RTS, real-time strategy games, RTS, like Age of Empires, there's a
I know
lot of
about them. Yeah.
entities, right? That's all moving.
Yeah.
So how do they do
Yeah.
this? Okay, that's a tricky question, right? Because like you said, it's not possible to send all the states, like thousands of them,
Yes.
like every other second, right? And also it's not
Mm.
necessary. Why? Because most of these entities, they move with a predictable, predefined model, behavior model. Okay, they could be NPCs. I mean, obviously there are
Mm.
players, but most of the entities are just AIs, are bots. Okay, are
Yeah.
NPCs. So what happens is what they send are simply players' commands. You see,
Mm.
like
Mm.
my mouse click at that spot, I want to move this unit there. You see, that kind of
Oh.
command. So
Okay.
obviously, this may involve, again, maybe some position. Yes, true. However, you have to note that this only occurs when a user has pressed a button, has issued a command. You see, so
Mm.
the frequency of which is not that regular. Also, it's not that frequent. It's only when a human does something, then a command is
That
sent.
sent.
You see,
Okay. Yeah.
and what happens is this is where the bucket comes in. Bucket means that there's some predefined bucket interval where you will wait, for everyone. Let's say you have like four
Oh.
players, you see, wait for all their
Okay.
commands to come in. And then you use those commands and obviously sorted them by the timestamp order.
Mm.
And then just execute the whole simulation according to the
At
current
once.
game states and these, updates. You see?
Wow. Okay.
So this is how they are able to simulate thousands of units. And they pretty much would act and move in the same manner across all the machines, literally.
Okay.
You see? Because it's the same, because if the initial states are the same and if the updates are the same, then it's a finite state machine, right? So all the
Yeah.
outcomes will be the same. You see?
Yep.
This is how Age of Empires keep its consistency. Does that make
Nice.
sense?
Yes. Yes. I mean, the bucket
Okay.
thing just
Yeah.
clicked.
Right. So usually in update-based model, what happens is the packets being sent are usually a lot smaller, less frequent. Okay.
Okay.
But also you cannot have too many, participants playing together. Okay. Obviously there are game aspects, but usually it's limited to like 4 to up to like 16 players at most. The reason being, you can imagine this is not really a scalable model. You
Mm.
see, because let's say you have 100 players, okay, and you
Yeah.
need to have to wait the bucket for all the 100 players to receive their commands in order to proceed to the next game step
Yeah.
frame. It's going to be a mess, right? It's going to take
Yeah.
a lot of time. You see, and usually the communications between these peers, they are through TCPs because they need to be
Yes.
delivered reliably.
Yeah. Yeah. I
Okay,
noticed that.
so
Yeah.
this is the difference between update based, it's reliable TCP usually with smaller commands, versus the state based model such as
Okay.
FPS.
Okay.
Okay, which basically sends out lots of positional packets. And even if you lose like a couple of percent of them, it's fine.
Okay.
Okay.
Yes,
All right.
yeah.
So now does it make sense? These two main models.
Yes. State-based versus bucket-based.
Okay.
Okay.
So I just let you know the two main consistency models out there. Okay.
Okay. No, thank you. That was quite helpful. Because I noticed quite a lot of
A lot of work,
let's
right?
say terminology, yeah, and
Right.
it was a bit
But if you really look at them, their mechanism, and really think through and break down, you can see they typically belong to one of these two. You see?
exactly.
Okay. Yeah, and then you can understand their models and their use case relatively quickly.
Okay.
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 All
Yeah.
right. All right. So yeah, I think this is important that you have this background knowledge. And
Yes.
yeah, so please continue.
Yeah. So basically, yeah, that I saw a lot of information on different synchronization types. So not only were there consistency types, there were like synchronization algorithms. Let me even use that word. Yeah, they had like algorithms that were used to establish synchronization. And I feel like that I feel like this needs to go into the research like extensively, because I don't think I put
Okay. Okay.
this. I never like
Okay.
considered this to be quite important. But also I noticed there was a what's this thing called, the timeout challenge, right?
Okay. Okay.
For example, like when you send data, right? You have sent information. How long does the peer wait? Now, when we use certain types of synchronization type, I mean, certain synchronization types, it's almost like each algorithm has a specific timeout, like period.
Okay.
Now, the question is, how do we sort of determine what the worst case scenario would be, if that makes sense?
Okay.
in our
Okay.
case, right? Like, how would we determine the worst case scenario? Anyways, but that's a like again, I think that's a question for
Okay.
another day. But
All right. But I do have to ask you a question though, because
yeah,
consistency, another side of this is that you really have to ask about what is the tolerance range. You see?
tolerance.
Tolerance. Okay. For example, like in Age of Empire, okay, in RTS
Yeah,
games, there's low tolerance for okay, or maybe let me put it another way. Maybe this is not a good example. Games typically will require a high degree of updates, and
yeah,
like it has to be very low latency. Okay, for games, all right, which is
yeah.
understandable, right? Because you're interacting with someone, and it's action based, it's fast paced. However, for some other types of applications, for example, like Uber, okay,
Mm,
for Uber, maybe the accuracy, if you're doing it within, let's say, 1, 3, or even 5 meters, right?
yeah,
You see, even if the data between what the taxi drivers looks at or what the central server is looking at are off by, let's say, 3 to 5 meters, it
mm,
may be all right.
okay,
You see,
yeah.
okay. So the application tolerance range actually has a lot to decide or to influence, like how consistent you should
Okay,
be.
okay.
Okay, that does that make sense?
Yes.
Okay, so I guess another important thing is when you're talking about or measuring about your quality or your performance in terms of latency and consistency, you sort of have to answer first. What are the scenarios, the use case that you are supporting or you're looking at?
Okay.
Okay,
Mm,
is that okay?
yeah. The
Okay,
the use case. Yeah.
so I guess I want to ask you this question. I mean, what do you feel that the main use case is? I mean, like, what is the tolerance range for?
Uh, Geez. From a general point of view, or from the for from our specific application point of view?
Okay, that's a good question. Actually, I would like to hear both. Okay,
Both.
and
Okay.
potentially you can start with the specific. Okay, but then I think we can see if we can move it to the general model. Okay.
Lens range.
All right. So
Okay.
what is the specific?
So for the current application,
Right. Yes.
the major major will be position. Major
Yes.
The
Okay.
major
Right.
application, right?
Okay.
It's basically
Yeah.
getting the
Okay.
the
The positional
location.
state, right?
Yeah, the
Okay.
positional
And what
state.
is the tolerance range, fault tolerance for this?
Uh,
Like how off can they be while the, I guess the whatever application you want to support or use
can I
case
use
can still function?
percentage?
Yeah, sure, yes.
Sure.
Percentage wise
So
is
I
fine.
think 70% is fine because it's not.
70%.
Yes. I know from a real-time perspective, it's not
Uh-huh.
great, but for
Okay.
what we need it for, because at the end of the day, the basic idea is to track location of devices,
Okay, I see.
right?
Okay. And
So
so,
the devices are mostly static. It's not.
okay.
They are not. They are not constantly on the move. They're only on the move once in a while.
Okay.
So if they are static, it doesn't necessarily have to run unless
Right.
there's an action or
Okay, I see. Okay.
so yeah. So that's from a um the factory perspective now.
Right. Okay.
From a
But then,
bigger
what are the important? I guess what are the important data you are collecting?
um yeah location one
So you do need to know the
state, the
position's
location,
accuracy.
yeah, the position, yeah, the
Okay.
position. So I'm guessing from a position perspective, we're talking about an accuracy from maybe uh 1 meter.
Okay. And why
one
is that?
meter
Why do you say it's 1 meter?
If it's 1 meter, the idea is 1 meter is probably in the room, or because most times factories are subdivided into like sections. Or
Right. Okay.
if it's in a storeroom, the idea is you want the location of that device to be within a certain range in that storeroom. I know
Okay.
1 meter. I'm probably pushing it because I noticed with there was something I learned with drones. Their positional accuracy is not necessarily 1 meter. Sometimes it's slightly. They say 1 meter when you set up the system, but when it lands, it doesn't land at the exact position. It's just
Okay, I see. So are you saying that it can be off by more than 1 meter or less than 1 meter?
let's say one less than or equal to 1 meter.
Oh, I see. Okay, so within 1 meter, basically,
Within one
that's
meter,
kind of
yeah.
the tolerance range, right?
Yes.
So you're saying if it's within 1 meter, then it's fine. It's still fine
Yes.
for the
It's still
application.
fine. Yeah.
I see. Okay. All right. So besides position, any other data that's
The
usually that needs to be collected, and do they
the
have
the
to be in
time.
order?
So not necessarily in order, but we would also want to know how long it takes for the information to arrive.
Okay.
That's the
So you
that's
mean the speediness of that
the
is
speed
also
in
a
it.
quality
Yes.
measure,
Yes.
right? The latency.
Yes. Yes.
Okay.
But that is not necessarily for the factory now. This is for analytical purposes from a big
Okay.
picture
So what do
perspective.
you think for the factory? What are the key, I guess, the key things that sort of has to be in place?
So at the beginning, my goal was location and basically data acquisition, right?
Okay.
When I'm in data acquisition, for example, the temperature of a room, the pressure, instead of connecting all of that to a server, um, it sort of distributed. But I don't know if they would allow that.
Okay.
Because
What do you
they would
mean? What
have
do you
to.
mean if they will allow that?
They have some like sensitive equipment. I don't know if how often they do maintenance on them. I also don't know what the process is. For example, in a radioactive environment, are we allowed to make changes to this entire design
Mhm.
um,
Okay,
of
I
the
see. Okay.
of the sensors, for example?
Oh, I see. Okay. Okay.
But I think it will be possible. I just don't want to get my hopes up. That's
Okay.
why I'm sort of focusing on the
I
position
see.
or accuracy, the state of the how do I put it now?
Okay, I see. So basically, you're saying that the main data you want to collect is simply the locations for all the
Location, yes,
sensors that's laid
yes,
down at various places in the factory.
yes, yes. And if there's one added, or
Why
should
is
I
that
say,
important? I mean, what is the
um, so the goal is to develop the framework to handle that, like dynamic
okay?
sensors, right? So you have static sensors and you also have sensors that are moving around.
I
For
see.
example,
Okay.
when they move a device from one place to the other. So rather than connecting that location, for example, say they move the say a router, let's say CNC router, from the office to the factory, right? The idea is the moment the router gets to the factory, it auto connects to the network that already exists in the factory,
Okay, I see.
right? So
So
it's
that
like
it can be plugging, right?
it's sort of just plugged, yeah, and then it's sort of, so the nodes around it recognize it as a new node, so they evenly distribute the resources. So the goal at the moment, or at least my goal, is that
Right.
this is a test, what do you call it, case study, or a test case rather, that okay, if this platform works, then what can we do when we add new features like data acquisition, or
Okay,
should I
I
say
see.
data storage, or real-time data, which I think it's already going to be real time in terms of the location,
Okay,
but because the nodes are sort of static, we might not be
I
able to
see.
get the
Okay,
results,
all
yeah.
right.
Um,
How,
and
however, it's not just collecting this information, right? I mean,
mm,
you have to collect them for some purpose,
for something,
right?
yes, yes.
Yeah. What is that purpose?
So what a lot of what the division I work with will be working with is rather is analytics. Right? They're trying to sort of analyze what's going on at certain locations in in the factory in general. So
Okay,
sometimes
okay.
they have devices, say, what's 10 minutes? Let me think of this now, like almost a kilometer away from the main, factory. So instead of walking all the way to go check out, maybe there was a problem or something, they can simply just check it on their computer.
Ah, I see. Okay. So the
So
sensor what provides things like temperature, right, or other
temperature,
kinds
yes,
of
pressure,
measurable. Okay,
yes, and,
okay.
and
I see.
voltage,
Voltage.
and so. But instead of all of, because what they wanted to do was IoT based, but the problem with that is a bit expensive. I think they had like this subscription they were paying for every year, where the service provider provided them with this, like a server based front end to
Okay, okay.
visualize,
All right.
right?
Okay.
But last I checked, this the subscription expired, and they were looking for something better, basically.
Okay.
And
All right. Okay. So all right. So Victoria, here's some feedback. All right.
okay,
I think from what you just mentioned,
mm,
I think the use case is quite different from the game. Okay, from that of
okay,
games. Because what happens, if I'm thinking, one of the things that could be potentially, a quality measure is,
yeah,
let's say, for example, like how distributes can you place the moving nodes, or how
yeah,
efficient can you place them, or maybe like how fast can you make their deployments, right?
yeah,
Because one potential question could be, how can you place the least amount of sensors but have the widest available coverage,
mm,
right? I mean, that could be
yeah,
one topic, right? And and the other thing is obviously when you are collecting, like, can you collect it in such a way that it doesn't overload any specific nodes or causing exceeding delays, right?
Yes.
So for example, if all the latency of the data being collected are under some bounded constraint, let's say
Yeah.
no more than 5 milliseconds, for example,
Yeah.
right? Then that would be a good quality metric,
Okay.
you see?
Of
Okay.
course.
So I guess what I'm trying to say is uh, this this application, you have to sort of describe and define the application,
Okay.
okay, the requirements first. And then the quality can only be defined in terms of the actual application requirements.
Okay.
You see?
Okay.
Okay.
Yeah.
And
Yeah.
this is something I like you to think about, which is can you make this a more generalized model? Okay.
Okay.
In the sense that, obviously, smart factory is one use case, right?
Yeah.
However, like you could have things like vehicles, right? Like if we talk about
Yes.
like a delivery service, right?
Yeah.
Where the meters that right now it's less than a meter, right? For delivery
Yeah.
service, maybe up to 5 meters is acceptable, right? Maybe
Okay.
the latency of up to like 5 seconds is all right. Okay, right.
Okay.
For 5 seconds is all right, right? But the key thing is, can you make this a distributed architecture so that, for
Mm.
example, one, it doesn't need to rely on a centralized server or a centralized bottleneck, and two, it can be a lot more scalable, right? And maybe like energy cost efficient, right?
Yeah.
This could be important when you are deploying centers in the fields, right? Where they may not have infrastructure-based communication, or it could be like too expensive or too much of a hassle to install like APs all over the place, right?
Yeah.
It's better to have the nodes to communicate with each other, right? Things like that.
Yeah.
Okay,
Okay.
so I guess I think this is it would be nice if you can
Okay.
describe how should consistency be measured given on different sort of application requirements.
Okay.
Okay, like let's say the application requirement is a certain meter, right? And the
Yeah.
latency is a certain milliseconds, right?
Okay.
Then how can you show that your protocol, whatever we will be offering, developed as a solution, can actually fit, right, into the
Yeah.
application requirements for their
Okay.
consistency?
Okay.
Okay,
Yeah.
that makes sense. I mean,
Yes. Yes, it
the,
does.
the, okay, and the reason why I'm trying to say this is that again, uh, you want to have some quality metric that is definable, okay, is applicable to your specific scenario. But
Mm.
also, if you can sort of generalize that to other scenarios, then it will be quite useful, you see, for other
Mm.
people or researchers or people in other fields to adopt
Yeah.
your research for their own
Okay.
use while
Yeah.
still having the metric relevant and useful,
Mm.
you see.
I see what you mean.
Okay, so I
I see
think
what you
that
mean.
should be the goal when you are trying to define a specific metric.
Okay.
Okay, does that
I
make
see what
sense?
you mean. Makes sense. Yes.
Okay, all right. So I think already. I think if you can just maybe a bit finalize that in terms of
Okay.
what is the consistency matrix you will be using, and maybe like this generalized model, you know,
Okay.
um, then I think you're good. Okay. And the
All
next
right.
step I would say
Mm.
is I think we should start to. Okay, so the problem actually we also describe a bit today, in fact, which is how can you maybe distribute nodes, right, in the factory scenario, so that it
Yes.
can be at the optimal placement, for example,
Mm.
within
Yeah.
some short amount of time, right?
Okay.
While collecting things, collecting data within some bounded latency,
Yeah.
right? Because if you can achieve that without infrastructure, just decentralized, then that would be
Yeah.
quite useful, right?
Yeah. Okay. Okay.
Okay. So I think as a next, maybe write down the problem statement. Okay.
Okay.
In terms of what exactly the problem that you are trying to solve. And I think Herman and I we can sort of feedback on whether that's a problem statement that is both specific to your application, but also generalizable to
Generalized. Yeah.
wider applications.
Okay.
Okay.
Yeah. Okay. I see what you mean.
All right. Okay. So yeah.
I
So
do.
I think finish off the consistency thing, and then maybe work on the problem statement, and
All right.
try to define more clearly,
The
like what
requirement.
is the problem you are trying to resolve.
Okay.
Okay, and what will the solution potentially look like? You can also, even though you haven't described your solution, you can talk about what does it potentially look like what characteristics must it fit in order for us to call it a good solution.
Okay.
You see?
Okay. I see what you
Okay,
mean.
that is usually also helpful, useful. Like the potential solution when you're defining your problem.
All right.
All
Yeah.
right. Okay. So Victor, is that all right?
Thank you.
Or
Yes. Yes. It is all right.
okay. Okay. All right. Sorry, it takes a bit more longer.
No, it's fine.
Because
Listen.
I like to, sort of feedback on the consistency concept. Okay,
Yes.
because I think
Yes.
that's going to serve you in the
Yes.
in the
In the
future.
future. Yeah.
All right.
Okay.
Okay. All right. So, any questions?
Thank you very. For now, not any.
Okay.
Oh
Okay.
yes, I wanted
Yeah.
to say on Thursday I'll be traveling in the morning, so I
Okay.
think I'll miss that. I'm gonna arrive. I'm going to Joburg in the morning. I need to
Okay.
go
All right.
somewhere.
So
But
Thursday, will you be joining or not?
I won't be able to join. All right.
Okay. Okay.
But
I
I
see. All
think
right.
based what we've discussed now, maybe I'll just work on it and put it on the group.
Sure.
And
Sure.
then
Sure.
if you
All
have
right.
a
Okay.
chance,
All right. And on Friday we have the mastermind. You know that, right?
yes,
At
Friday
the
I will
same
be
time.
available on
Okay.
Friday, definitely.
Okay. All right. So
All
maybe
right.
we'll talk then. All right.
All right. All right.
Okay. All right.
So
So thanks. Yeah. Thanks a
thank
lot.
you
Yeah.
very
And
much.
talk then. Yeah. Yeah. Bye bye. Yeah. Bye. Bye.
Bye.
Victor.